The James Webb Space Telescope is the largest, most powerful space telescope ever built. It will allow scientists to look at what our universe was like about 200 million years after the Big Bang. The telescope will be able to capture images of some of the first galaxies ever formed. It will also be able to observe objects in our solar system from Mars outward, look inside dust clouds to see where new stars and planets are forming, and examine the atmospheres of planets orbiting other stars. The JWST was a collaborative project between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Northrop Grumman, a US-based aerospace and defense company, was the main contractor responsible for building the telescope. Main purpose of making James Webb Space Telescope is to look deeper into the universe than ever before, capturing light from the first stars and galaxies formed after the Big Bang to study the formation of stars and planetary systems, to analyze the atmospheres of exoplanets and search for signs of habitability, to explore objects within our own solar system in ways previous telescopes couldn't. Total cost of making JWSTs is approximately $10 billion US. This figure includes design, construction, testing, and operational costs. Development time of JWSTs is nearly 25 years. Work on the telescope began in the 1990s with delays and technical challenges pushing its final launch date to December 25, 2021. The James Webb Space Telescope has several unique features that make it extraordinary and different from other telescopes, particularly the Hubble Space Telescope. Here are some fun facts about the James Webb Space Telescope. JWST's primary mirror is 21 feet in diameter, about 3 times larger than Hubble's. This massive mirror is made of 18 hexagonal segments coated with gold to enhance infrared reflection, enabling higher resolution and greater sensitivity. The Webb telescope is as tall as a 3-story building and as long as a tennis court. It is so big that it has to fold origami style to fit inside the rocket to launch. The telescope is unfold, sunshield first, once in space. The James Webb Space Telescope sees the universe in light that is invisible to human eyes. This light is called infrared radiation, and we can feel it as heat. Firefighters use infrared cameras to see and rescue people through the smoke in a fire. The James Webb Space Telescope will use its infrared cameras to see through dust in our universe. Stars and planets form inside those dust clouds, so peeking inside could lead to exciting new discoveries. It will also be able to see objects, like the first galaxies, that are so far away that the expansion of the universe has made their light shift from visible to infrared. The JWST telescope's cameras are sensitive to heat from the sun. Just like you might wear a hat or a visor to block the sun from your eyes, it has a sun shield to protect its instruments and mirrors. The temperature difference between the sun-facing and shaded sides of the telescope is more than 600 degrees Fahrenheit. The JWST has a 5-layer sun shield about the size of a tennis court. This shield protects the telescope's instruments from the heat of the sun, earth, and moon, keeping them cool enough to observe faint infrared signals without interference. Some instruments, like the mid-infrared instrument, MIRI, are cooled even further, close to absolute zero, to reduce background infrared radiation. Space telescopes see by using mirrors to collect and focus light from distant stars. The bigger the mirror, the more details the telescope can see. It's very difficult to launch a giant heavy mirror into space. So, engineers gave the Webb telescope 18 smaller mirrors that fit together like a puzzle. The mirrors fold up inside the rocket, then unfold to form one large mirror in orbit. A thin layer of gold helps the mirrors reflect infrared light. The JWST orbits the Sun at the second Lagrange point, L2, about million miles from Earth. This stable location allows the JWST to maintain its position relative to Earth and the Sun, making continuous observations without Earth's interference. At L2, the JWST avoids Earth's shadow, allowing it to constantly cool and remain in a stable thermal environment, which is ideal for infrared observations. The JWST's instruments, like the Near Infrared Spectrograph, NIR-SPEC, and Near Infrared Camera, NIRCam, allow it to analyze exoplanet atmospheres for signs of habitability, such as water, carbon dioxide, methane, and other molecules that could indicate life. High sensitivity and resolution of the JWST can capture extremely faint objects and details in distant galaxies, helping scientists study galaxy formation, evolution, and star formation processes. The JWST's design enables it to tackle a broad range of astrophysics research. Its goals include studying the evolution of galaxies, star formation, planetary formation, and potentially identifying biosignatures in exoplanet atmospheres. Overall, the JWST's specialty lies in its ability to see deeper, in greater detail, and across a wider range of the infrared spectrum than any telescope before it, providing unprecedented insight into the early universe. Our solar system isn't the only home for planets. Scientists have discovered thousands of planets orbiting stars other than our Sun. These are called exoplanets. The James Webb Space Telescope will help to study the atmospheres of exoplanets. Could the atmospheres of some exoplanets hold the building blocks for life? We will find out soon.